This is the video guide for Class 3 Assignment 3, and we're going to be doing a thematic map based on US Census data. To get started, we're going to need table data and also the geometry itself. So we'll first start with what we call a bundled product from the US Census. And if we navigate to the location for Tiger products, this is the actual name of Tiger, we can see our data options here located in green. And this is the first step of our class assignment. So to accomplish a mapping, we essentially have 6 steps that we need to do. So the first one is we're going to download our data. We're going to point our GIS to what's called a geodatabase. We're going to review calculating area in a table. We're going to discuss table joins a bit, and then we're also going to deal with demographic variables. And in the mapping for this tutorial video, I'm going to map household income in the past 12 months at the county level. So we're going to be using 2 columns. We're going to be using all households, which is the global estimate for all households at the county level. And then we're also going to be using one particular variable for households that have the highest class of wealth, which would be $200,000 or more in household income in the past 12 months. And this is all based on 2015 data. So this is going to be one example of one variable of census mapping, and your assignment is going to be to replicate these methods that we utilize here in this tutorial for a particular variable that you're interested in. We're going to also normalize this based on the total population, and we have a formula, which is our variable divided by the global count times 100. And then we're going to finally discuss classification methods for the mapping that we're interested in performing. Okay, so to get started, we're going to be using the Census Tiger data here, and that's this table. And we have many different options in terms of download here. A good place to start is just to work with the Tiger line selected with demographic and economic data, which is the third one down. So we click on that. And we're going to be using the American Community Survey, which is a 5-year estimate. So we're between, this video is 2017. So we're a little bit more than halfway between 2010 and 2020 census. So it makes sense for us to use some of the estimate data that comes from the American Community Survey for our particular time period. What's important to realize is that this particular 5-year estimate is dated up to 2015. We just need to keep that in mind. So if we go into 2011 to 2015 detailed tables, we have many different geographies here that we can download. And certainly for your mapping, for this first part of the assignment, for the main part that's due, we're going to be mapping at the county level. So we want to download all counties for all of the United States. So we see it about halfway down here is county, so we're going to click on that. And this is a 188 megabyte file, so I'm just going to let this download. I'm going to pause the video and let it download to my desktop. Okay, I unzipped this file, and we can see it here zipped. The unzipped version gives us what's called a geodatabase, and the file extension for that is .gdb. If we open that up, in this format outside of GIS, it's not very useful at all. So we just need to realize that we have a special file type here that we need to bring into GIS. So I'm just going to open up ArcMap for that. And I'm going to point it with ArcCatalog to my data source. So we'll come down, Geodatabase. And now we can actually see it. And the icon for a geodatabase is, it looks like a little storage container, a trash can gray thing, and that's a geodatabase, the visual icon for it. If we open it up, we can see we have what are tables here. That's the visual icon for tables, And at the very top, we have polygon geometry. So this is our actual county geometry for the boundaries for the polygons. And then underneath, we have all our tables. And of course, this comes all bundled up. It's very organized and contained. And this is a great place to start doing census mapping to get familiar with how the tables are set up relative to the geometry. So this is kind of a helper data set to get familiar with mapping census. But it's not the end-all be-all of the whole census universe, and in the extra credit map we'll push beyond these pre-formatted geodatabases. So for now, to get started, what we want to do is just bring in the actual county geometry and look at it for a second. So what we have here is we have the contiguous, called the lower 48 United States counties. And then we have Alaska here, Hawaii, and then Puerto Rico, and there's some smaller islands off to the side here too. When we do our mapping, we're probably going to lose some of these smaller geometries off to the side, but we are going to have the continuous United States counties, and those would make up the bulk of your map that you're going to produce for this assignment. You can also use some of the techniques from class 2 where we created map inserts. So if you want to have Hawaii and also Alaska in your map, we're going to do 11 by 17 sheet. You'll have plenty of room to insert those as map inserts next to the contiguous counties, and that would be a nice approach. Okay, so to get started, let's take a look at the data itself. So if we open the attribute table, let's take a look at some of the things we have here. So we have a name, and so these are the county names themselves. And there's a code here. There's a GeoID. And what we're going to be joining on is a special code called GeoID data. And this is a string file. And the reason it's a string is we can see that US is stuck in the middle of this long number here. And this number is just a concatenation of states and county numbers and also the actual county number itself here. So this long number represents several numbers coming together into one continuous expression. So if we do a right click and we look at the properties, we can see that this is a string column. It's really important to realize that this is a string column, and that's what we're going to actually be using as our join column. The other column that's interesting is that there's a land column, and this is measured in meters, square meters, and this number represents square meters of that particular county in the records that is land and not water. And of course, since we're mapping demographics are going to take place largely on land. That's where people live. That's where people that all the demographic data responds well to landmass, especially when we're doing normalization for square areas. So we're going to also be working for a moment with this column. Okay, so we have a metadata file here, which is county metadata, and this is a very critical file, is the metadata file. So the metadata allows us to see what each one of our column short names represents. So for our mapping, we want to, for the video here, we're going to do household incomes. And this column is B1900 1E1. So if I can go look for that right now. So it's B down to the, I'm just going to come through here on this column. You can see I have 40,000 records, so it goes on quite long. So I'm looking for my B19s. It's going to take a second here. I'm going to pause the video until I find them. It'll just give me a second here. Okay, it took me a second to find my columns I'm interested in, but I found them. So each one of the themes that's represented in the tables has a total population. So in this case, I'm looking at household income in the past 12 months in 2015, and it's inflation adjusted dollars in this case. And I'm looking for the total households. This is the start of the thematic series. And then I'm looking for the estimate. I never want to be in the margin of error. The margin of error just gives us back a confidence number of the actual estimate itself. But the real number that we're mapping is the estimate number. And I want to, this is my total population. And my actual variable is household income in the past 12 months, 200,000 or more. So that's going to be top earners. I could pick any of these columns here. So if I wanted to, I could be mapping individuals that are between 10,000 and 15,000 or 25,000 and 30,000. But in this particular instance for the video, I just want to map those, what we might call, the top earners, sort of the 1%ers. We want to find out what's the percentage in a county that has that type of earner. So we're going to be using those two columns, and I've jotted those two columns down so I know. But to do your mapping, you need to walk through the metadata and figure out first what's the theme that you're interested in mapping. So here we can see a break. So right above it is a ratio of income to poverty level. So if I was interested in mapping this thematic, I would first need to get the total population, and then find underneath the total population the variable that I'm interested in mapping against that total population. So it's two variables that you want to grab out of the metadata, and you're going to jot those down. So in my case, I've just put those here in step 5. I've said these two columns, and there's a formula that we're going to use here to create a normalization for our mapping. Okay, so now that I have that notated, I want to actually do my mapping itself. And the first mapping we're going to do before we get into the income is we'll just do a basic counts. This is pretty easy to understand. The counts column, if I bring that in and look at it for a second and open it up, the counts column is pretty straightforward in terms of population. So we're looking at a population count per county. So if I look into the metadata, at the very top here is a unweighted sample count of the population. So this is the number that I'm interested in, is just mapping the total population, and then we're going to normalize that total population based on square area. Okay, so we need to jot down this particular column. That's the one that we're interested in. Okay, so we have two things here. We have both a table and we have geometry. And the first thing we need to do is we need to bring the table data, the demographic data, make a join with the actual geometry. And the way that we do that is we go to the geometry itself, and then we do a right click, and then we say join. And then we're going to point the join to the table. In this case, we want to do counts. We're not dealing with income at all right now. We're just going to do counts. And I need to find my join columns. So in this case, the join column for American Community Survey geometry is going to be this GeoID data. So I click on that, and then it's going to see in the counts data a likely join column. In this case, it's called the GeoID. So let me just back up real quickly. So if I go over here to counts and say open, this is the column that I'm mapping on, and we can see that number is very similar. So it's some digits, and then US, and then we have some digits after that. So if we go to properties here, we can see that this is a string type. It's critical to understand that we need to, when we're joining, we need to be column type identical to the column that we're trying to join to. So if we do run into problems where one's, say, a text and we're trying to join to a string, we should make them both strings or both texts. And that's not hard to do. We can do that. Okay, so let's go back here. We're going to do our join, and there's the GeoID, and we need to make sure that we're on the right column, or the right table. So we're doing counts, GeoID, and we're going to keep all records. We're going to validate the join. It's going to run through and check the columns, make sure that they look okay. Now we can see that we're dropping a few records here. So it's we got 3,220 out of 3,233. So we're losing something along the way. So we say okay, but it's not very much. And we can find out what we're losing. So if we go to open the attribute table and we come over here to our farthest right hand side, right here is where the join breaks. So we joined geodata to our counts table starting right here, and you can see it has these little asterisks here. Now the key thing here is to realize that this current join is not solidified. It's not permanent. So if I were to just crash or go away right now and not save anything, this all would go away. So we're in kind of a temporary state right now, and we need to solidify that in just a moment. But I just want to discuss this real quickly here. So we have this join that's taken place, and now we have this new column that's available for us to actually map. So before we go too much further, let's go ahead and figure out those nulls first. We need to do that. So we go over to the far right hand side, and let's just sort ascend, and our nulls will come up to the top. Now what we can do is we can just select these. There usually won't be very many. We'll select these right here, and then we can see where those are located. So obviously this is relatively inconsequential to the larger mapping. It's these small territories, and we can actually see the names of those territories. So these are island type territories that are off the contiguous counties. So for right now, I'm just going to leave these in. You could certainly get rid of these and do your mapping. You could keep them in. There's several different approaches, but what's really important to realize is that these do not have any recorded value for our particular variable that we're mapping, which is population. Okay, I'm going to clear out that selection. Then the very next step here, before I go much further, is I want to just export this out. So I'm going to data export. I could export it to a folder if I want to, but in this case, I'm just going to export it to the default geodatabase. So here's default geodatabase, and I'm just going to call this C3 demo 1. And I'm going to save it as a feature class here, not as a shapefile or anything else, just as a feature class. And save it and say OK. And this is the file that I'm going to work in now to do the rest of my mapping. So if I come up, I'm just going to turn that off. And here we go. And I'm going to do a zoom to layer. And then I'm going to kind of get into so I can see the lower 48 here. So this is kind of what we want to map. This is the bulk of our mapping. Okay. So now we're going to open up the attribute table, just preview it real quickly. Everything looks good, and we can see that we have a solidified join now. This is all stable, so if we want to use this in the future, it's going to always have this particular attribute table associated with it. We could simply map right now based on this variable, which is our total population count. Let's just go ahead and do that real quickly. So if we go to properties and go to quantities, and the value here is going to be this column, this E1 column, which is my population count. And I'm just going to accept the basic natural breaks at 5 classes. So we can see at my very top I have close to 80,000 people, or 800,000 within a county. So a lot of that's going to be probably out in California. So we say apply, OK. Yeah, and we can see that we have some counties that have really high numbers here. Not a lot, but a fair amount do. But what's important is that we're mapping a absolute number that has not been normalized. So the normalization that would make sense here is we want to know the density of persons. So we want to know how many persons per square mile would make sense. And at that point, then we'll have New York showing up very high because Manhattan, obviously, it has a very small square area, but a very dense urban population. So to do that, what we need to do, this is normalizing for square area. And that's different than normalizing to a population. Is we're going to open up the attribute table, and we have this column in the Tiger data that's called a land. So that's area land, and that is in square meters. So if we were to use that to normalize, then we would be saying persons per square meter, which is such a small unit of measurement, it doesn't really work that well. What would make more sense is maybe persons per square acre, or in our case, we'll do per square mile. So what we need to do to set that up is make a new column. And we go into the top left-hand corner here and say add a column. This is going to be a double. And we can just abbreviate it so it could be SQ underscore MI for square mile and say OK. And then we need to run a formula on this column. So the formula is 1 square mile equals about 2.5 million square meters. So what I need to do here is I need to take my A land divided by that number. So I'm going to go ahead and do that right now. I'm just going to copy this little formula here, and I'm going to go over to square miles and say field calculator and say OK. And square mile is now going to equal this column. Let's see if we can find that column. Divided by, and I'm just going to paste in my formula here and copy that, divided by that number. Okay, so I'm saying square meters divided by its representation of a square mile, and say OK. So now I have a square mile column that should make a lot more sense. And you can test this out to make sure that you got it right if you know a county. I know that certain counties equal a certain amount, so I'm just going to quickly search. So if I go to select by attributes, I'm going to find the name, county name equals, get unique values. And I'm looking for, I'm going to do Sullivan. I know how big Sullivan is. Equals Sullivan County. Say apply. OK. That didn't seem to select it. Let's try it one more time. OK, that looks correct. Let's try it one more time. So I'm in the correct, I was in the wrong data. So I need to go into demo, click on that, say equals, get unique values, and I'm looking for a county that I know, apply it, OK. And it gives me 6 back. I can say show selected records here in the lower left-hand corner. And I'm just going to pick out the one for New York, which is 36. State 36 is New York, and he's 968. So that's exactly correct. So the square mileage in Sullivan County is 968 minus water. So here's the water calculation. We're just doing land. All right, so now that we have this particular variable, then we can use that as the denominator for our actual population. And then we can get population per square mile. So that's what we want to do. We want to normalize on square area. So let's go ahead and make sure that under selections, we clear the selected features. Okay, and here we go. We're going to go to properties. And there's 2 ways to do this. We could do it in the table, or we can actually just do it on the fly through our graduated colors within symbology. And that's what I'm going to do to start. So what I want to do is I want to take this column. Remember before we just mapped it with normalization. This time we're going to put on normalization for square miles. And this I'm getting persons per square mile now. So under label, I might want to simplify this number a little bit. So let's bring it down to 2. That looks pretty good. And then say apply, OK. So when I make the map, it's going to be persons per square mile in my legend. Okay, so this needs to be retitled. So this would be persons per square mile. And we can see now we have some somewhat dense in Los Angeles and the Bay Area, it looks like. Let's see what county that is. Yeah, San Mateo. So up by San Francisco, we have some very dense areas. And of course, the big outlier here is New York. So if we take a look at the Bronx and Manhattan, we can see that our square mile is 69 and our population is very high. Now the other way that we can do this is we can go into the table and say open attribute table, and let's clear everything out. So selection, yeah. Let's open up that attribute, and we're going to take off this properties and just make it a single symbol. Say OK, and open this up. Why is it not going? Oh, I'm not looking at the full, I'm looking just at show selected records. I want to go to all the records. So here, what I can do is make a new column and say add field, double, and I can do PPL for people per underscore SQ mile and say OK. And I could set it up in the column if I want to, and I would just go to field calculator, say yes, and this is going to equal my population column, which is this one, divided by my land, or actually my square miles, I'm sorry. Great. So some of these obviously are really small, so we have kind of a small numbers problem here actually. So if we sort ascend, we have our nulls, but then we have some very small numbers down at the bottom. But as we get down towards New York, we could see that we have some of these counties that are very high in population. So that's normalizing within a table and then normalizing also within symbolization. And either one is okay to do. Let's go under properties. Let's walk through some of the different options that we have in terms of symbolizing. So graduated colors, let's put our value in now as our column that we just made. And instead of natural breaks, let's do a standard deviation and take a look at what that gives us. So under standard deviation, I'm not going to exclude anything right now. I'm just going to run it and say apply OK. And let's take a look at what we got. So under standard deviation at 3 breaks, we can see that there are a lot that are below standard deviation number. There's a few right in the middle there, and then we have these other counties, interestingly enough, that are significantly higher. So these are going to be Chicago and the New York area, and then Southern California, San Francisco. So it's not the most exciting map in the world, but that's kind of how we normalize based on square area. And we can go ahead and save this now as a shapefile if we want to, or we can just leave it in the geodatabase. That's perfectly fine. Okay, so let's go ahead and do the mapping for our actual variable for income now, which I think will be a little bit more interesting. So instead of counts now, I'm going to get rid of this particular shapefile, and we're going to go back to our original. We're going to make sure that there's no join here. So I'm going to remove any joins, remove all joins. And now I want to point it back to my art catalog, and I'm going to bring in the column for income. So income is X19, so I'll drop that in. I'm going to get rid of the counts. Okay, and for income, I'm looking for the column, these two columns, B19001E17 and also B1901E1. So I got to go find those two columns out of my income. That's what I'm going to be mapping to. So to get started here, let's go ahead and do a join. So we have that done. So I'm going to go to join and relates, join. And I'm going to put it to geodata ID, data, and I need to make sure I'm in the right column, income. You'll see GeoID and validate it. And I should get the same number. I should get a few dropping out. So yeah, again, I get 3,220. I say close. And then I'm going to send this once again to geodatabase. And I'm just going to call this, I'll call it census underscore income. Say save. That'll take a second. And then what we need to do is we're going to now normalize, not on square area, but on actual population. So let's keep in these guys so we know our metadata. I'm going to get rid of this. So I'm mapping census income. So if I open up the attribute table, I am looking for, I have a join now on all the income data. So all this is income data. It gives me a shape area. It gives me also the land and the water, but we're not going to use those to normalize. We're going to normalize on the population. So in this case, we just need to keep in mind those two columns. So I went through the metadata and I found the global for household income for the past 12 months. So that's everybody in that column. It's an estimate. Okay, so it's that number. And then I want to normalize for the 200,000 tranche. So we could do that pretty easily if we go to properties outside of the table and go to quantities. And our value is going to be B1900 1E1. So let me see if I can find that. Give me just a second, I'll find it. I'm going to pause the video for a second. Okay, that took me a second. I didn't realize that the values were sitting right up at the top, so it took me 3 or 4 minutes to figure that out. So what we have here is the first value is the smaller population, not the global population, and that particular variable was B1900 1E7, which is this one. And the global population for all households for income is B1900 1E1. And what that gives me now is, actually this should be not 7 but 17. Let me get back into 17 here. So a bit of a trick to get this exactly right. So here it is. Yeah, that's correct. So what we're doing here is we're normalizing our variable for households with wealth of 200,000 and above based on the total population. So if we go back to our calculation here, it's household incomes in the past 12 months, which is total households. That's this column. And then I'm mapping the 200,000 household tranche. And this is the calculation that we would run in the column. But for right now, I'm just going to do it interactively in the window here. So here's what it looks like. Now, this is actually a percentage. So we need to go up to labels and go to format labels. And under percentage, we can now express this. Let's bring it down to 2. Say OK. And some of these tracks are all the way up to almost 30% of households are making 200,000 and above. And those are going to be, my guess is right around New York City. So let's give this a shot. So this is a 5-class natural breaks normalized column. Apply, OK. And yeah, we can see quite a pattern here now. And we can see that we have a lot of counties that just have a few individuals or individual households that are making that type of dollar amount. But then we have scattered around the country these very specific tracks. And then certainly if we zoom in to New York here, we should see a lot that are, remember these are counties, so we see it's hard to make them out a little bit. So here's New York or Manhattan. And Manhattan, although there's lots of tracts within Manhattan that aren't nearly as high based on percentage. We see that the actual full borough of Manhattan, or the county of that Manhattan's in, is in this last break here. Okay, so although we don't think of this whole surrounding area as being completely above 200,000, we just need to realize that based on our percentage, we have individuals or individual households between 12,000 and 26, or excuse me, 12% and 26% that are making that type of dollar amount for household income. So we just need to be careful what we're actually mapping and how we're going to express that. So when we actually produce the final map here, we would need to make sure that we're disclosing exactly what's being mapped in a legend. So instead of it looking like this, we would want to say for the title of the legend, it would percent of households greater than 200K. So 200K, or we'd express it some way here to note that this is the percentage of households in the county that are above 200,000. So that's how we normalize kind of on the fly. Let's do it just to close up. Let's do it actually in the column too. So if we go into the column, we go all the way down to the end, and we're going to make a new column. So we say add a field. It's going to be a double, and we can call this call it percent 200K, and then we're going to run our field calculator. And under field calculator, the trick here is that we just have to get the columns right. So I already have those, so I'm just going to go into my little cheat sheet here and run this formula. So this column equals the column called B1901E17 divided by B1901E1 times 100, and say OK. And this is going to take a moment because we're going through 4,000 records, or close to 4,000. And there we are. There's our percentage. And then we can just simply map on that number if we want to. Now we still have the null problem. So there's a couple ways to handle that. We could send the nulls to a outlier number, like a minus 9999 if we want to. We could also exclude the nulls. There's a few different options, but just be aware that those nulls are there, and you may or may not want to have those in your final mapping, because those could be considered an outlier to your data. Okay, so the final turn-in is going to be for the map that you produce for the assignment is going to be at the county level. So you're going to download the county level just as we did. You're going to go through the county metadata file. You're going to pick out the variable that you're most interested in, denote those columns. So in my cheat sheet here, I have the columns already established. Then I'm going to pick a classification method that I want to map with. So under properties, remember we're doing natural breaks here. That would be the default. You might want to do standard deviation or one of the other types of classifications, depending on what you're trying to present in the final map. It's up to you. Don't feel like you have to stick with natural breaks by any means. And you want to pick a variable here that you would like to map. So you might be interested in poverty, you might be interested in health insurance rates. There's lots of different options here, languages, educational attainment. This is a very rich portfolio of demographics that you can map on. And for this mapping, you're probably going to want to normalize to the population. So to do that, remember, we need to go into our metadata. And under metadata, you need to first figure out which variable you want to map on. So let's take a look real quickly. Let's do sex by age, white alone. So that column starts right here, and you can see there's a break between sex by age for females and then sex by age, white alone. Okay, so that's going to be the global population is that number, the estimate. And it's always usually starting with A's and ones. And then you want to find the variable that you want to map against the global population. So maybe for sex by age white alone, I'm really interested in finding white males that are above 85 years. That would be this column right here. So I would replace the two columns that I used for the tutorial with this one, AM16, and the global population for sex by age is, for white alone, is this one right here. Okay, so this takes a little bit of attention in the metadata to get your global column relative to the variable that you want to actually map and you want to normalize based on the full population. And remember, sex by age white alone, the estimate number, the global population, will be slightly different, or it could be similar or the same. But if I was mapping on another variable, say sex by age, this estimate may be a slightly different number. So you don't want to just take a global population from another thematic and apply it to the thematic that you want to actually map. You need to be within that thematic that you want to map wholly, both the smaller variable and the global population itself. Okay, so once you actually have your variable decided, then you'll do a map layout 11 by 17, and in the map layout you want to make sure that you definitely have a legend. You don't necessarily need a scale bar or north arrow, but you need to have good titling, good map sourcing. You need to use helpers and text explainers to contextualize what's actually being mapped thematically throughout the map itself at the county level.